Okay, so let's get started. We're going to be taking a look at working with our closed loop Lambda control. Once again, this tutorial we're going to be focusing on setting up and programming a narrowband sensor into our closed loop Lambda control. This is a little bit specific. I wanted to have a dedicated tutorial on this topic. You may find yourself in the situation where you're calibrating and tuning, let's say, a G4X plug and play, such as a Honda S2000, that runs a narrowband sensor factory. You can still enable and work with your closed loop Lambda control. We have to do things in a little bit more specific manner compared to running a wideband Lambda sensor doing a typical wideband control with our closed loop Lambda. We're going to talk about how to set that up and configure that in the next tutorial, but this tutorial is dedicated to our narrowband style closed loop Lambda control. All right, let's jump in here and talk about some basics, some details here to understand what we're trying to go after with our programming. What we're going to do is move from our basics page, and I first want to jump over here into our analog inputs. Now, when we're setting up our narrowband sensor, we have to tell the link where the signal wire is coming in from that narrowband sensor. So we'll find narrowband sensors are typically 4 wires. One wire is going to be our signal out, then another wire is going to be for some type of a ground, and then the other 2 wires are going to be for a heater circuit control. Now, we're only worried about right now setting up our signal from the sensor coming into the link. And that signal is going to be ranging from 0 to 1 volt. Now, a wideband Lambda sensor is going to have a broadcasting range of typically 0 to 5 volts. So what we're dealing with here is that at 0.5 volts, typically, that's going to be the equivalent of stoichiometric or 1.0 Lambda. We're going to tell the link to focus around that 0.5 volt range of where we want to keep the voltage reading so that we know we're allowing the engine to run at stoichiometric or 1.0 Lambda idle part throttle conditions. But we need to go and tell the link where that signal is going to be found, which analog input we've wired that into. What I'm going to do here is not configure my narrowband sensor under my settings right here. Typically, we have our Lambda 1. When we configure this, we've had a couple tutorials talking about this. We set this up for a wideband sensor, whether it's going to be a CAN wideband, it's going to be an analog voltage style wideband, or it's going to be an internal wideband found on the Link G4X Fury, or our G5 Voodoo Pro, for example, has 2 built-in Lambda sensors. We do need to have a Lambda sensor reading in order to properly do any full throttle tuning. We'll find the narrowband sensors are only accurate again at stoichiometric 1.0 Lambda. When we go full throttle, we're not going to run at that lean. So we have to have some type of a wideband to get an actual airfield reading, Lambda reading under full throttle. We may or may not be setting that up in here. Right now, we're focused on just configuring and setting up the narrowband sensor for our Lambda control. So what we're going to do is move from our analog input window here and jump over to our closed loop fuel. Now, under our Lambda mode, we have the ability to turn this on and to actually set up our closed loop mode for our narrowband. We can find Stoich mode, narrowband is what we want to choose. Now, you can set up the Stoich mode with a wideband, but in my opinion, that does not make sense. Usually, if I'm going to be setting up a wideband Lambda control, I'm going to be doing that using the auto mode, which allows us to apply the closed loop correction at idle, part throttle, and wide open throttle. We're not focused on just stoichiometric or 1.0 Lambda in the operation. So I'm going to go ahead and choose this narrowband option. Again, that's the focus of this training module. What we're going to do right now is jump down here under NB Oxy Source. This is our narrowband oxygen sensor signal source, where we've wired the signal wire from our narrowband sensor into the link. So we're going to go here. In my case, I'm going to choose analog voltage 3. You'll choose whatever analog voltage you have that signal wire wired into. Let's click OK. Now, the first thing we're going to notice here is that the analog 3 is showing here 0.49 volt. The scale or range of a narrowband sensor is always going to be between 0 and 1 volt. So if the voltage is higher or lower than approximately 0.45, 0.5 volts, that means that we're either richer or leaner than stoichiometric. And the closed loop control is going to be looking at this specific range, this specific voltage point, and it's going to base all of its control around that. And that's what's known here, if we scroll down just a little bit, as our dither voltage. The dither voltage is going to be the exact voltage that should correspond to 1.0 Lambda. And in this case, it's either going to be 0.45 to about 0.55 volt. The best way to determine what this is going to be is to actually have a wideband fit it to the exhaust stream, so a wideband lambda sensor and your narrowband sensor. And then what you can do is run it without the closed loop control on, so you could just run it with all your kind of default settings here at idle, and compare your wideband reading to your voltage, specifically under your analog volt that you've assigned here. So in my case, if I see on my wideband display that it's showing approximately 14.7, when my analog volt is measuring here about 0.5, 0.49 volt, that's going to be the dither voltage I enter in here. This will be a little bit different for different narrowband sensors, but typically we can enter in 0.5 if we're not sure of what it should be, enter in 0.5 right here. I would set your low and high voltage to 0 and 5 volt because we don't want this playing any role in error detection for our analog voltage sensor, for the narrowband sensor, because it has the ability to go all the way down to 0 volt and it has the ability to go all the way up to a volt. So we want to go ahead and just increase that range in terms of what it's looking for. So the next thing, since we've set up our voltage input here for the signal and we've set up our dither voltage at approximately.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.